In the previous video, we looked at the first characteristic of the ideal op-amp model. And we said that the first characteristic is that the output is going to be dependent only on the differential voltage. It's not going to be dependent on the inverting and the non-inverting inputs, but only on the difference of the two, right? Now Vd is of course the difference of the two voltages, the non-inverting and the inverting inputs. And also we said that in an ideal op-amp, this differential gain is going to tend to infinity. Now, I want to talk about the second characteristic of the ideal op-amp model, which is that the currents that go into the input terminals of the op-amp, I in plus and I in minus, those are going to be equal to 0. Now, what do I mean by that? So let's just draw an op-amp circuit here. It's got two inputs and an output. Okay. Now, if you are applying a voltage at the non-inverting input and the inverting input, you would expect that there could be some current that would flow into the circuit here, right? Because this is just a symbol of the op-amp. Internally, there are some resistances and other electronic components inside the op-amp, and therefore it needs some power from the input to work. So this current is called the current at the inverting terminal, and similarly there is going to be a current at the non-inverting terminal, and both these currents we are saying is 0. The third characteristic of an ideal op-amp model, and this is the last one, is the fact that we'll assume that the op-amp can give as much current as is required. So I output is not limited. Okay. Now what is I output? Now, just like the input that is flowing into the inverting terminal and the input that is flowing into the inverting terminal and the non-inverting terminal, similarly the current that flows out of the output is called IO. It is the current that's flowing out of the output terminal, or perhaps it is the current going into the output terminal. I mean, it could be either way. What we are saying is there is no limitation for the output that the op-amp can supply. Now, what that basically means is that this op-amp can supply an infinite amount of energy to its output. Now, we know that that's not true, but I think in an ideal op-amp, it is helpful to make that assumption, because then we don't have to worry about what is being connected here, because whatever is being connected, this op-amp will be able to supply enough power to it so that the op-amp is not loaded. Okay, so in other words, we have already learned about loading. So in other words, what we are saying is basically that an op-amp cannot be loaded. Okay, so that's our third assumption. So these are the three characteristics of ideal op-amps, and we are going to use this to make circuits and to develop op-amp circuits in the next video.